Example 6. Radar stations A and B are on an east-west line, 8.6 kilometers apart. Station A detects a plane at C on a bearing of 53 degrees. Station B simultaneously detects the same plane on a bearing of 323 degrees. Find the distance from B to C. Round to the nearest tenth as needed. All right, so this is going to be our first bearing problem. With bearing, you absolutely have to draw an illustration, okay? So let's go ahead and begin with an east-west line. So that just means from left to right, okay? So I'm going to draw one of those. So here we go. And on this line, we have points A and B. So I'm going to put them somewhere. Okay, so here's point A, and let's say here's point B. Okay, and we are told that the distance from point A to point B is 8.6 kilometers. Okay, so this distance is 8.6 kilometers. So I'm going to go ahead and label that. And then from both of these stations, a plane is detected. Okay, so it says the point that the plane is at is point C. Okay, so let's first read about station A. Station A detects the plane at point C on a bearing of 53 degrees. Okay, so from point A, we need to draw in the bearing. Okay, so remember how we draw or how we illustrate bearing. Okay, at point A, at that one particular point, I'm basically going to draw a north, south, east, and west kind of cross. Okay, so here we go. If we're looking at point A right here, okay, you can see in blue what I put, the cross. So this would be north, south, west, and east. Okay, and the bearing is given by a single angle. Okay, so actually what I'm going to do here is I'm going to extend the north line. Okay, if the bearing is expressed as a single angle, it is relative to due north. Okay, so let's say this is due north. Okay, so the way you're going to draw the bearing here, okay, is we would align ourselves with due north. Okay, so right here, and then you're going to rotate clockwise 53 degrees. So I'm just going to eyeball that. Okay, let's say it's about, let's say about right here. Okay, I'm just eyeballing it. So this angle right here is going to be 53 degrees. Okay, so that's how we would draw the bearing. So that means this is going to be point C. Okay, and this is where the airplane is going to be. And yay, this is my plane. And it doesn't even really look, I don't even know. It looks like a flower. That is not a plane. Okay, I don't know how to draw at all. Let me try again. Okay, here we go. Woo, there's the plane. Okay, that looks a little better. More kind of like a spaceship. Anyway, moving on. That is how you're going to draw the bearing for station A. And then we know station B is also detecting this plane at the same time, but the bearing from station B is going to be 323 degrees. Okay, so we're going to do the same thing. I'm going to put it in a different color. At point B, I'm going to make a cross to represent north, south, west, and east. Okay, and I'm going to make the north part a lot longer because bearing here is again a single angle, so it's relative to due north. Okay, so I'll go ahead and label this. So from point B, okay, this is going to be north, south, west, and east. Okay, so this time the bearing is going to be 323 degrees. So we need to draw here. We need to align ourselves with due north, and then we need to rotate clockwise 323 degrees. Okay, so this is going to be 90 degrees. This is going to be 180 down here at due south. Okay, then this is going to be 270 degrees. And so basically 323 degrees. And again, I'm just kind of randomly drawing this. It's just eyeballing this. Okay, it should detect the plane right here. Okay, so this angle from due north all the way around should be 323 degrees. Okay, so this is how you need to draw the setup. Okay, all right, so our goal in this question is to do what? Okay, well, if you look at the last sentence here, the goal is to find the distance from B to C. Okay, so this red line right here, okay, this guy that I just put a double hash mark on, that is what we're trying to calculate, that particular distance. So we need to come up with a plan on how we're going to calculate this length of BC. Okay, just start doing things. Okay, so try to figure out what you can work with. Okay, what this information in front of you can get you. I'm going to start by trying to figure out some of the angles in the picture. Okay, so anything I figure out, I'm going to write in green. Okay, first thing I need you to realize is that if I look at station A, when I set up the north, south, west, and east line, this is a perpendicular right here. This is a perpendicular. So this is a 90-degree angle because north, south is perpendicular to east, west. And we know that this angle, this 90-degree angle, is kind of cut, not in half, but it's cut. One of the angles is 53, so we can figure out what this angle is. Okay, so if I just do 90 degrees minus 53 degrees, that is going to give me 37 degrees. Okay, so this is a 37-degree angle right there. Okay, that might be useful. Let's do the same thing with the bearing information from station B. We can figure out this angle over here in green. Okay, so we know one full revolution, if we look at the north, south, west, and east, okay, this is going to be a right angle as well for the same reasoning that we had a right angle for the directions on station A. Okay, and if we go all the way around from this point and then circle all the way back, one full revolution is 360 degrees. Okay, we almost went one full revolution. We went 323 degrees. Okay, so we can figure out this particular angle inside the triangle. Okay, what we can do is, if you think about starting at due north and then you go through quadrant 1, you go through quadrant 4, and you go through quadrant 3 to end up here, that's 270 degrees. So I went a total of 323 degrees. If I take away 3 of the quadrants, that's 270 degrees, and that is going to leave me with how many degrees? That's going to leave me with 53 degrees. Okay, let me make sure that's right. Okay, so this is also a 53-degree angle, and that's this green angle. Okay, so I'm going to just draw right here. This is a 53-degree angle. Okay, so if I now look inside of this triangle that I have formed here, okay, and I'm talking about this yellow triangle that I'm highlighting, okay, I know 2 of the 3 angles inside of this triangle. Okay, I have a 37-degree angle. I have a 53-degree angle. The angles inside of this triangle have to add up to 180. Okay, so if I take 180 degrees and I subtract out the 53-degree, or sorry, I subtract out the 37-degree angle, okay, that green angle, that is, hang on, let me color code it. This green 37-degree angle right here, okay, if I subtract that guy out, and then I also subtract out this green 53-degree angle, not talking about the blue 53-degree angle, I'm talking about the green one, okay? If I subtract these guys out from 180, look what's left. 90 degrees, okay? So this is a right triangle, okay? So we can go ahead and say right here at point C, this is a right angle. Okay, we have confirmed that. You can't go into this assuming that. You have to prove that it's a 90-degree angle. Okay, so now that we know that, we can use right triangle trigonometry to come up with the length of BC. Okay, so let's go ahead and label. We know the side across from the right angle, this is going to be the hypotenuse, and we actually know the length of the hypotenuse, okay? The hypotenuse is the distance from point A to point B, and that's 8.6 kilometers, okay? So we know that. Again, we are interested in this red side over here, BC, that's marked with the double hash marks, okay? I need to pick one of the angles inside the triangle, either the 37 degrees or the 53 degrees, and run with it, okay? I'll pick the 37-degree angle because if I go straight across from it, the side that I'm looking for is the opposite side. That's my unknown, okay? So I've got the angle, I am looking for the opposite side, and I know the hypotenuse, okay? So relative to 37 degrees, I know the opposite over the hypotenuse, okay? Opposite over hypotenuse is sine. So I can go ahead and say that the sine of 37 degrees is the opposite, which is our unknown, okay? I'll just call it BC because that's what we're looking for, okay? Over the hypotenuse is 8.6 kilometers, okay? So we are left with this trig ratio, okay? And we need to solve for the side BC, okay? So all we need to do at this point to get rid of the fraction on the right, since there's an 8.6 in the denominator, we need to multiply by it on the right. Then you'll have one in the top, one in the bottom. They will cancel. Since I multiply by it on the right, I've got to multiply by it on the left. Okay, so these guys will cancel. We're going to get that the length of BC is going to be 8.6 times the sine of 37 degrees. That's what we need to pop into the calculator. You need to make sure you're in degree mode, which we are. So we're going to have 8.6 times the sine of 37 degrees. And then here we are, and I will write this out, this in full decimal expansion. This is going to be 5.17 5609 199. Okay, so that is the length of BC. And now we need to round. Okay, in the directions it says to round to the nearest tenth. Tenth means one place after the decimal point. Okay, so here's one place after the decimal point. You've got a 7, so this 1 is going to bump up to a 2. So we'll go ahead and say that the length of BC is approximately, because we're rounding, 5.2, and we need to put units on this. Anytime you have an application, you need to include units in your answer. And so BC is a distance or a length. So it needs to coincide with how length has been measured in this question. It has been measured in kilometers. So the length of B to C, the length between those 2 points, is approximately 5.2 kilometers. Okay, we are done. Keep in mind, to do this problem, you did not have to set up the ratio with sine. You could have used any of the right triangle ratios, okay, as long as you had the needed information to do so.